Okay, today we'll be looking at web basics and HTML. And as we all know, or a good number of us, if those of us that actually gone on the free camp, we already know that HTML simply means hypertext markup language. It's actually the one of the languages used for the web. It's a simple language I really wished I started with. So I started programming without the knowledge of HTML and CSS. And it actually gave me a hard time when it came to the point of building applications. I can probably tell you I'm a backend engineer and know little or almost nothing in HTML and CSS. So you probably will be listening to the wrong guy, but at the same time, you might be listening to the right guy. If you really want to follow yourself on web programming, I think one of the first languages you should follow up should be HTML. Yeah, and don't mind my cat. My cat is actually wishing that it learned the same language that I did. Okay, so a brief history about HTML. HTML was hypertext was actually invented. So HTML it's a language that was built over hypertext, right? And then hypertext was actually invented by Ted Nelson, right? And actually what hypertext actually enables us to do is to enable file sharing over servers. That's from one computer to the other computer, right? So when you have like a link on a text or something and you click on it and it routes you to a different page, what basically is happening is that page is actually a file, because when you're building HTML pages, you actually write all of that basically on a file, right? And then that links you to that file, and that file is actually sitting on somebody's computer somewhere, right? A computer that is actually connected to the internet. And once you get a link to that file, it displays on your browser and you can actually see all the information that have been placed in that file for you to see, right? So that is just the whole concept of hypertext. So it enables you to actually get files from different servers. And basically servers are nothing more than just computers. The computer you're using, your phone could also be a server, your laptops, your desktops, yeah, a good number of gadgets actually can serve as your server, right? So it depends. So what the server basically means is a computer that's actually giving out a file or giving out a content. Good. So Tim Berners was a physicist. He was working with, he was actually a contractor with CERN, and he proposed HTML to them when he had like a project to work with them on a file sharing system, right? And they actually did not wish to adopt that HTML thing, but they were using it under the hood. So they didn't want to come out to say we had something like this, right? Until sometime in 1993, when Tim Berners actually went out to the Internet Engineering Task Force and then gave them the first statement actually on it. And they made a draft for the HTML1, which lasted for 6 months, right? And then after validity, IETF actually now started working on the second version of HTML. And then they worked on that. The third version was actually supposed to have been developed by them, but because of politics, they couldn't go ahead with it. And so World Wide Web Consortium, that's W3C, actually took over that development, which they were working on HTML3, and then did HTML4, 4.01, and then 4.110, I think so. Yeah, and then so HTML5 actually did not start as a project in W3C. It actually started with Web Hypertext Application Technology Working Group, which is WHAT-WG. And before they completed it, they had to, because documentations and approvals were already undergoing standardization with W3C. So they had to join to make that as a deliverable with W3C so that they can have that completed and standardized so that it can be accepted, right? So they did that, and currently HTML is actually managed by W3C. And as we all know, or as a good number of us know, what we actually work with this day is actually HTML5. We can actually still take some tags from the previous ones, because when you do like an upgrade or in system, actually you don't throw out everything. You could just downgrade some other things and make good use of other things that have been existing, right? So how the web works. Yeah, so here I was able to pull out some information or some pictures. I had to pull the computers of the internet and then take screenshots of my browser. So you can see this is my browser here, and here's my browser too. Okay, so here Wisdom opens his browser on the internet and connects on his internet. That's an internet connected computer, right? You have to be connected to the internet. And then he types this website and hits enter. So what basically happens is the website actually is a link to a page or a web page, right? But the thing is, websites are just names, or we call them domains, right? Now, domains are, for instance, I want to call Deborah. I won't tell my phone to call Deborah. I will search for Deborah and then get her number, and I'll call the number, right? So because we cannot keep saving numbers in our head to call always, we chose to say, okay, why not let us save these numbers with names that we can easily remember, and then we can always, anytime we want to make a call to that number, we just search for the name and then we have the number. Now, that is how the internet in a way works. Now, what it does is there's something called the DNS, which is the domain name system, right? So this is like a phone book for all IP addresses. Now, what are IP addresses? We'll come to that, right? Let's just have that in our head. So IP addresses are actually unique numbers that are assigned to every computer devices. So your laptop has a number that is unique to just it alone, right? Your phones have numbers that are unique to just it alone. Every device that have the ability to connect to the internet actually have a unique address, right? Now, when you register a domain to an address, what you simply mean is you register a name that can be remembered, and they actually have a pattern that they follow, right? You have the .com, you have the .com.ng, you have the .us, and the rest. Now, those are actually extensions. Now, before the .com, the .us, the .uk, .ng, and the rest, right? Before that dot, what you have before it is actually called the domain name, right? So you have my website here, and my website is basically the domain name, and then the .com is the extension. So it means that somebody can have my website .us, and it will not be the same as my website .com, right? So if there's already a my website.com and I want that website myself, what I will do is I would either meet the person and buy that domain name from the person so that they can re-register that name to my server or my computer, whichever one I want to use, and then I put the address to it. So what happens is your browser or your computer make a call to the closest domain name system, right? And then runs that name on it, which is my website.com. Now, if this domain name system, the closest one to your computer, does not find the mywebsite.com on its list, what it does is it makes a call to the closest domain name system to itself, and then it continues that way until it's able to find the mywebsite.com. And then what it returns to you is the IP address. Now it returns to you the IP address. Now you under the hood now, or your browser under the hood now, makes a call to that IP address requesting for a certain file that they want. Now, the moment it makes that call to that IP address, what is doing it is connecting to another computer seated somewhere in the world. It could be Europe, it could even be the computer beside you. It could be probably some computer sitting in the Aso Rock, and you probably need a file from Buhari himself, and that computer has that file. So you could be making a call to that using this, right? And this is the unique IP address for this very computer we have here. Now, when you make a request to this computer has a file sitting there, right? And that is a request you're making to it. So if you make a request, say you have mywebsite.com and you have /home, what you're asking for it is, I need you to give me that file on your computer that has the name home, right? And it would give it to you, right? Okay, so yeah. So now what happens from this point is it renders that file back to you, and your browser under the hood now takes this file and renders it to something that is readable for you. Like for instance, if you can see here, after making a call to mywebsite.com, the browser actually returns this request. So if that request exists, right, and if that IP address really exists, what happens to your browser is your browser now saves that IP address to that name. So it means that whenever you're making another call to mywebsite.com, it has already made a memory cache, right, of the domain name and then the IP address. So it does not have to go back to the domain name system, but it will just go straight to that very computer that it has previously called, right? I can see here, this is saying this is my website and not Facebook. Okay, so at this point, I would like to ask, at this point, do you have a question before I go further?
None yet from my end.
Okay.
Venue also.
Okay, so from if you do have any question at any time, you do well to call me back to it, right? Good. Okay, so yeah. Good. So here.
Question.
Okay.
So you.
Hello.
All right. So what
yeah.
you basically saying is that when I try to reach out to an address, it doesn't go directly to the main source of that whatever site I'm going to. It goes to a computer nearby, right?
Yes. Go ahead.
All right. So what if that computer is offline? Like most of the computer around, they are offline. Does it still access that computer?
Oh, okay. So so there are different protocols that the computers actually work with, right? And a good number of them is actually the shortest path, right? So now what happens is the domain name system is a business on its own, right? It's just like let me say an eatery, right? An eatery, what their business is to make food and serve it to people, right? So if you are certain that you're hungry, or if you are hungry, you know where to go to. You have to go to this place and then get food. So at almost no time would you ever be certain that if you go there, you will find food. Anybody who probably is in the business of making money should know that I have to be live and ready to give anybody food. Now, these domain name systems, right, are there to ensure that their systems are up and running 247 and 366 days in a year. I know that we have 365, but they have to ensure that it has to be up and running 366 days. Now, the idea is when you make a call to that domain name service, it's like a phone book. It should be ready for you. But if that server is down, right, they do have backup. So if that server is down, it would actually move to the next. It will move to the next server, which is probably another computer somewhere, and then it keeps checking until it finds that name, And once it finds the name, it will always have to return to you this. Now, note that for the very first time you make that call, if you have noticed it anytime you're making a call to a website that does not, that you have never made a call to before, it takes a longer time. But the more frequent times you're making to that same website, you discover that it loads faster. What happens is this. It has actually, your brother has actually caught the trip of going to the domain name system to get the IP address, because once he got it for the first time and made the request to that computer, what it did was it saved that IP address in your browser. So the moment you're making that call for the second time, the first thing it does is it checks within your computer. Do I have this name saved? If I have this name saved, take the IP and make the call. Do you understand?
Okay. No, but I just take on the computer.
Any other question before we go to the next slide? Hello, please. So while we are on this, I would we're actually using the free version of Zoom. So what we'll do is in the next 3 minutes, we all will leave, and then I'll start up. You just leave and join again so that we can continue from where we stop. So now, while we're doing this, so how the web works, right? I just explained all of that to you. So we said Wisdom opens that, makes all of that call to my website.com and hit enter. Then for the browser to know where it gets the IP address, to know where to get the IP address, right, of the web server hosting the site, it connects to the nearest DNS and then gets the IP address from there. And then the browser makes a call to the IP address and keeps that information, right? And get the information in it. So quickly, let's jump into some web concepts that would like to use or would like to probably meet sometime. And one of them is actually, so it said the web is also known as the World Wide Web. So the www we see is actually what we call the web, right? And what this web is actually is an application, right? It is not, it's just an application that runs on the global network of interconnected computer networks. Now, before we go further, I have to explain something to you. We are always hearing about the internet, the internet, the internet. Now, question is, what is the internet, right? Internet is basically a short, which is internetwork, and internetwork of connected. Okay. Yeah. So, like I was saying, so the web, as you said, I was talking about the internet. So the internet happens to be a network of interconnected computers. Now, before now, what we actually do was have our computers do stuff for us, right? So we had issues with just one computer being a computer, and we wanted to expand communications, right? So we had one computer connecting to the next computer, and they kept moving files from each other, right? Now, that admits a network, right? Now, so in a company, when they have computers connected to themselves, we can term that as intra because it's within the system, right? Now, when computers actually begin to connect to external systems, right, in different places, we can now keep that as an interconnected network of systems of computers. Now, before we move further, so we have. Okay, sorry about that. We're looking at network types, right? And we have basically two types of network. We have the client and the client server network, right? Here is where computers, so there are some computers that have the information that you want, and some computers actually get the information from that place, right? For instance, when you visit your browser and type google.com and you have the Google page, right? There's a computer that actually has the whole file of Google stored on it, right? And those computers are called the servers, right? And Your own computer, on the other hand, is actually the client because it is actually requesting that information from the server. So when you have a restaurant and you have somebody who is actually giving you food, you turn out to be the client because you're paying for it, right? And then the person who is actually giving you the food and taking your money becomes the server. So that is the system that actually works. So we have the client server system, which is the client server network type. And here basically it's, like I said earlier, it's some computers seated somewhere in the cloud, which obviously the cloud is some other person's computer, having the information that you need, and you making a request for it makes your computer the client. So that is the kind of network that we call client server network. Um, we have another network called the peer-to-peer. I don't know if a good number of us know what we call the torrent, this torrent downloader, or if anybody ever used that. Now, what peer-to-peer actually means is every computer is going to serve as a host, right? Which is going to be a server, obviously. And then every computer can also be the client. So when you use uTorrent to actually make a call, or when you use uTorrent to download, say you want to download a movie with uTorrent, there's a big chance that that video, that uTorrent video you're trying to download, is actually somewhere in somebody's computer, right? Now, that person that you are probably downloading that video you're downloading from his computer is probably downloading something else from somebody's computer, right? And so it means that once you install uTorrent on your computer, you have the ability that whoever is using uTorrent, right? Because once you are done downloading, uTorrent asks you to seed. Now, the question, the whole concept of seeding is you are giving uTorrent the access to host that very video you have downloaded or a few informations on your computer within its own system. So if anybody is making a call, I want Legend of the Seeker, oh, that's really an old movie. So I want Legend of the Seeker. What uTorrent does is it spreads out among all its network, all the computers that have uTorrent and have allowed uTorrent to actually search them, right? What it does is it spread out to all of them. And then if it finds Legend of the Seeker in 7 computers, it means that it will be pulling those fragments from the different computers. So it makes downloading faster for you because you don't have to wait to pull all the information from one computer. You're pulling fragments from different computers. That means that the time you would have spent in downloading from one computer, taking fragments from that one computer, is being shared among 7 computers. So say the video is going to take like it's going to take like 7 hours for you to download, right? And there are 7 computers that have Legend of the Seeker. It means that it will take you roughly 1 hour because the 7 of them will take fragments, will send fragments to you, and fragments of different chunks that are not alike. So this will take maybe like the first part of it, break it down, and then bring all of that to your computer. Once your computer gets all of this information, it rebuilds it and make it that same file for you to watch. So a lot of people actually use that. So this is the type of network that is called peer-to-peer. So peer-to-peer means that this computer is talking to this computer without the need for a central computer, without the need to connect to one computer, and that computer connects me to another computer. So we are doing it directly, right? So every network or every computer that subscribes to the peer-to-peer, right, have their IP addresses registered within the computers in that network. So they can connect to anyone at any time, right? A good number of this type of networks, if you have your computer and you do the VPN, there's a virtual private network where you can connect to computers within. You also, when you use your Bluetooth, when you use your Bluetooth device to connect or send files to the next computer, you're actually using a peer-to-peer system. When you use Xender and turn on your hotspot and share a file with another computer, you are equally using a peer-to-peer network, right? So before I go further, I'd also ask again, do we have a question around this, please? Hello?
No, sir.
Okay. Okay, good. So, yeah. So, moving forward to more web concepts, we have the internet
Hello,
protocols.
I have a question.
Okay, yeah, go ahead.
Hello?
Yeah, I can hear you. Go ahead.
Hello?
Yes, go ahead. I can hear you.
Can you hear me?
Yes, I can hear you. Go ahead.
Oh. Okay, but if 7 of those computers have this file that you're looking for, it will be faster for you to download because they will be sharing the different um, fragments of the files, right?
Yes, yes.
So does that mean that the processing speed of your computer doesn't really matter?
No, no. So the processing speed of your computer would probably not matter that much because you know that you can actually download more than one file in your computer. You know that, right? At the same time. So yeah, so now that you can download more than one files um, into your computer at the same time, it means that whenever you make a call to download something, it actually starts a new process for you. So what uTorrent is actually doing is it's getting all of this in different fragments, and then once it's done getting all of them in different fragments, it reviews it for you, right? Like I said, if you're going to be downloading it directly from one site, right, it is still the same thing as though you're downloading from 7. Probably you have like 7 extra processes, which probably might not affect your computer that much. It's just like as good as you opening like 3 or 4 more tabs on your browsers. Hello. Hello, can you get me now, Ruben? Okay, so while we're waiting for Ruben to give us his response, let's go further. Okay, so here we'll be looking at more web concept, and here is the Internet Protocol Suite. Now, what is the Internet Protocol Suite, right? Like we said, we were talking about the IP address, right? And I told you that it was a unique set of numbers that the um, identify the very computer you are on. So every computer has a unique IP address, right? So the Internet Protocol is actually a set of rules governing the format of data that is sent over the internet or other networks. So it could be a peer-to-peer, it could be a client server, but the IP is actually what is governing it. So now because it's an IP, but we all definitely do have an address so that we can actually locate where this file is moving from and where this file is actually moving to, right? So the Internet Protocol has 4 layers, right? And the 4 layers, one of the layers is the application layer, right? And in the application layer, we have a good number of protocols that actually run. And one of the most common one is the HTTP and then the HTTPS, right? Which is the Hypertext Transfer Protocol, right? Now, this is the one that we commonly see when we open our browser and then we transfer files from, or we call, yes, obviously that files are transferred from the server to our browsers and then displayed for us to see, right? It's not just, your browser has a way of understanding how to display certain files. For instance, when you click on download, right, a file is actually sent to your computer, but you discover that the browser asks you to download instead of displaying the whole file on your browser, right? So this protocol actually helps your browser understand exactly what to do at what time with the file that's coming. We also have the FTP. You probably will not come across a lot of this, right? But I'll just point out to a few that you would probably meet. And why we call it the application layer is this is the topmost level that we can actually use, right? So this is the application layer is actually the level where applications on your computers or applications on your phones actually used to connect to the internet, right? Your browser cannot actually use basically some of these things without these certain protocols. There are more of these protocols, but I just had to highlight some of this for you. You can take out time to actually look at a good number of them. I would want to point out HTTP, HTTPS, which is a secured version of HTTP. I would also want to point out SSH. I would also want to point out SMTP. For those of you that actually usually set mails when we had our early phones then, SMTP was like the way to go about it. SMTP and IMAPS, right? We have FTP, which is the file transfer protocol. So this is moving files from a computer to another computer. Now, all of these protocols are actually used by applications that are installed on your computer or your phones, right? So your browser would use HTTP, right? And if you probably send FTP, some browsers would want to understand that, and some would refuse to understand it. SMTP actually are mostly used by your messaging service, which is Simple Mail Transfer Protocol. Probably would want to configure that most especially when you are configuring email service on your phones, right? And a good number of them. Some programmers actually use SSH, which is Secure Shell, where you want to have communications to another computer sitting somewhere, and the connection you want to do should be with the terminal, right? You get to see all of this as we progress in our programming experience. Yeah. So this is actually the application layer where applications actually connect to the internet. Now, the next layer we have is a transport layer, right? Now, transport layer is basically that is slightly below your application layer, right? Now, which is the TCP. Now, this does not just allow your computers to connect to the internet, right, through the application. The TCP, as is, actually controls and it verifies the information that the applications are actually sending or receiving. So they make a call, HTTP, right? And then once it comes back, these transport layers are actually the ones that pack it up, right, and verify that these informations are what they are supposed to be before it allows it to go further. So we have like a lot of them. Or one of the most common one I really want to point out is the TCP and the UDP. These are the ones that actually applications actually use most of the times to do all of this. So we move to the internet part of it. So here I would also want to point out two things here, which is the IPv4 and the IPv6, right? A good number of these things, you probably might not use them anytime soon, but I would advise that you take out time to just see what or appreciate what they do, right? So you could take out time to look at all of that. Now, the IPv4 and the IPv6, right, refers to the IP addresses that I was telling you about, right? So now earlier we had IPv4 before the upcoming of IPv6. Now this was a version of your IP addresses, right, that are broken into 4 places. Like if you remember, we had the 120.0.0.1, right? Now I will always remember that a good number of programmers will always tell you, I am at 120.0.0.1, which sometimes just mean I am at home, right? Which is your internal computer. So yeah, so there was a version of IPv4. This version actually breaks down these numbers into 4 chunks. So you have this chunk dot this chunk dot this chunk dot this chunk into 4. Now the coming of IPv6 actually broke it down into 6, like you could guess, into 6 chunks, right? And because more computers started coming into existence, and at some point we just had the feeling that would run out of addresses in the future. So that brought about the IPv6, right? These also have, you might see an address, but broken down into fragments again to cover for more address this in location in, right? Then the next or the last is the link layer. So the last, which is the link layer, is that which your computer actually connects to another computer seated somewhere. So it could be the computer next to you. It could be the computer that is actually serving, which might be your internet service provider or however it is. So the direct connection that your computer has with another computer. For instance, when you have your wireless turned on, like as I was telling you, right? Where you have your wireless turned on, and then something is connecting, you're connecting to a server that is actually broadcasting the internet to you, right? You probably are using the link layer to do all of that. Now, it is through this link layer that all of this that has been packed from the application, the transport, and the internet actually moves out of your computer. They could all be there, but as long as the link layer is not connected, right? It could be by a good number of times we actually use the internet, we use the Wi-Fi, we use tunnels, which are like cables and the rest, right? So all of these are being packed and then sent out through that link, right? So if your browser has HTTP, which will take all these information, pack it up the way it wants, send it down to the transport layer. The transport layer packs it up and verifies that this information is exactly the information that is meant to be sent, right? And then this sends down to the internet layer, where it will now try to figure out what IP address to send it to, right? If the link is not connected, it is not going anywhere. It remains in your computer. Probably tell you that either your computer is not connected to the internet, or maybe some error that you get on your browser, right? Okay, so yeah, before I continue with this, do we have a question on that? Okay, so since there's no question, we'll continue. Yeah, so here we have the IP addresses. Like I said, we have the two, which is IPv4 and IPv6. We've recently spoken about that. So we just move into a few more programming concepts. I spoke about the domain earlier, which is the name associated to the IP address, right? So, like I said, the domain name system has that registered, and it's just like a phone book and has that name and your IP address, or however it is. So whenever you make a call, it actually sends the domain to the domain name system, and the system actually returns to you back the actual number, just like when you're searching for contacts on your phone, right? We have the ISP. The ISP is the Internet Service Provider. That is the computer that your computer actually connects to, right? I don't know if you understand what I meant by that. So they are the one granting you access to the internet. If you have access to the computer that you create a link connection to the initial computer that is serving that, it is fine. But if you don't have a connection, the internet service provider is what is going to actually connect you. So when you have MTN, you have Glo, you have name them, right? They are your internet service providers. They're the ones that connect you to the internet. So you can actually, you possibly would not be able to get any information from the internet without the help of these guys, except you find a way to become your own internet service provider. Yeah, then when we talk about web clients, we basically are talking about your web browsers, right? They are the ones that actually make calls for websites. They are able to actually read, get all of those informations for you, and they do that with the help of user agents, right? So the user agents actually get the actual file from that computer, and the user agents are the ones that actually help you render these pages to the browser. So they have like a lot of engines within themselves, and a good notable one will be the V8 engine, which is for JavaScript. And yeah, so all of that we'll get to see and use them while we continue. We just have to grasp like a good concept of these names and understand how they do. You also should take out time to actually look at all of this too. So yeah, when we talk about URL is simply the web address, like we always call it, right? It's like a complete list of the web address. So when we talk about the domain name is just mywebsite.com, right? But the The URL is not just the domain, right, or the domain name, right? It is also a whole list of things joined together, which we'll be looking after here. So now we have a syntax. It says that the protocol, right? If you go back, you remember that there are a lot of protocols that come from there. So you probably will have FTP, you probably have HTTP, whichever protocol you're going to be using, right? You put that, and then you have the IP address for the server. So you have the IP address of the server where you want to make the call to, right? You can actually make the call. You can actually make the call to your own computer too. So if you use 120.0.0.1, it should be looking at your own computer, right? And it will be listening at a certain port, right? So if you have that, then you also want to know what port is actually listening, or what port is being listened to this call, right? So you want to have that all that it's connected to the IP address, right? Then the next thing you want to see is the location of the file in the server. Now this whenever you do a call to a server, the server has been configured to say this is the root. So if you make a call to google.com, right? Google.com probably would be a folder called google.com on a server, right? And that is the root. So when you do a slash, right, you're saying, I want to go to this file. So that slash is saying, move into that folder, right, and get something from that folder. Now, whatever you put in that folder simply means that is what you're looking for, right? I would have to show that to you maybe after this short presentation, or probably it's actually a very long presentation, but we're almost close to the end. So that location to the server could be a path, and then finally the file name. So the syntax is down here, which is the protocol, right? HTTPS, HTTP, FTP, however you want, and then column, then slash slash the host. So the host, which most of the times is ignored, is the www, which is the application, right? That so a good number of every application we actually have are mostly hosted on the World Wide Web, right? And it's the host, right? And then because it's hosted on the web, right? So that is our host when we are looking at web pages. And then the domain, the domain, and then after the domain, the port. Now the port is, you see, the computer has like a lot of entries and a lot of exits, right? Now what happens is, I think we have the ports up to there are a good number of it, right? Now the default port that the computer actually listens on is 80. Port 80 or port 8080, right? So it listens on this port, right? When it comes to hosting web pages and then allowing other servers make requests to it, right? It listens on that port. But for HTTP and HTTPS, it has a 443, yeah, port 443. And then, yeah, for HTTP it's 80, for HTTPS it's 443. And a good number of them. You get to know all of that. So now this port is whichever port that the computer is listening on and saying, if anybody makes a call to this port, right, give it this. If anybody makes a call to this port, give it this. So you can host more than one application on your computer, right? And we'll all see about that. So you host one maybe on port 80. So if you make a call colon port 80, you will get this application. You make a call port 90 or port 9070, however you design that to listen to, it will give you a different application. So the ports are saying, okay, what entries do we have? Because entry will determine what we're actually giving out to them, right? Then to protect, you have to ensure that a good number of all your ports are locked, and then the only ones you can allow to the public, because all the ports are open locally, but the ones you can allow to the public, right, should be the ones that probably have what you want the public to get, right? So because if you don't have your port closed, or you don't have your ports, you have them open, not private, then it means that somebody from a different place can actually get into your computers and get information that are not supposed to be gotten, which will be a very bad thing for you in your development career. Right. So as we said, DNS is the domain name system. So yeah, good luck to you on this very part of it, and then we'll be looking at HTML in the most shortest time. We'll just discuss briefly. I think we'll start with a discussion for those of you who have attempted Free Code Camp, and we'll just talk on a very light note how to start up or spin up the HTML. This thing we'll be doing like a live coding session, probably in the next 40 minutes. Yeah, so we would go on a very, very short break, say 10 minutes, and I just need all of you to recap on all that you've gotten. Yeah, and we'll come back. I would let you guys know on the WhatsApp page in the next 10 minutes so that we can start joining back. And then if you have questions, you can ask the questions on the WhatsApp page. If you feel someone asks a question and you feel you have an idea, you can actually put it. No idea is wasted. I think we are here to learn. We are also here to boost ourselves. So the whole idea is not to ensure that I should be the one blocking you, but it should ensure that all of us understand and all of us are being carried along equally. Yeah, so we can end this call now, and in the next 10 minutes, we'll be back here together. Thank you all.